our webinar on cabling in Altium Designer. So before I begin, I just want to start with some housekeeping. There'll be minimal time for questions today. Based on my prior runs of this webinar, it will take about 50 to 55 minutes. So if I can grab a question or two, I may. However, feel free to write those in, and we'll try to monitor those. So go ahead and feel to write those. If we don't necessarily get to you today, we'll certainly put together something like a Q&A sheet over here. But do be specific in your questions, especially because it matters. For example, text versus parameters. You'll see here today that there's a huge difference between using text and using parameters. So make sure that you're very specific about the terms that you use. And then lastly, as I mentioned, if there's enough questions, we'll create a Q&A sheet. If there's a lot of questions and things that I was not able to address, possibly another part 2 later on, or maybe just a smaller follow-up video if there's just not enough material to warrant a second webinar. So we are definitely going to be interested in your questions here today, because we know this is an interesting topic, and obviously we're using things in a very different way than we normally would in Altium Designer. So with that being said, let's take a look at our objectives. Number one, we're going to talk about using Altium off-label. What does it mean by using Altium off-label? We'll understand that a little bit better. This is a big thing, understanding the mechanical versus the electrical. Why is that? Because if you ever try to do this on your own, you may have stumbled, and that is because we mixed the two together. And ultimately, it took me 3 times to try to figure this out, and the 3rd time I realized we cannot mix the two. We really have to treat stuff as mechanical, electrical, or both. And you'll get a better understanding of that as we go along. We'll also talk about the types of components. In fact, we'll go through a library of some basic parts that would be, I think, enough to get you started on something like this if you wanted to try it in Altium. And of course, we have an example, and it's an example I created, and we'll be referring to this throughout the entire PowerPoint presentation, along with the things I'll show you within Altium Designer. So with that, let's start off with a polling question. I'm very, very curious to know what you're using for cable drawings. All right, so the results are in. Hopefully you can see them. It's really kind of an interesting spread. Everything from other people doing it to using a professional tool like SolidWorks Electrical or E3, and some of you are also using Altium as well. All right, so it's all over there. That's really cool. All right, well, hopefully by the time you're done, you'll have a better understanding of what Altium can provide for you, and then you can take it from there. Let's talk about Altium Designer being used off-label. What do we mean by with the pharmaceutical industry? Off-label means is that you're using something that it was never intended to be used for. So for example, if there is a medicine or medication that was created for a very specific purpose and the FDA approved of it, then if they find out later on that it can be used for something very different, then it can be prescribed or used in what's called an off-label sense. And so off-label means that there's no liability because you're not using it in the proper method or intent that it was originally created for. A really perfect example of this is aspirin, right? It's been around for about 120 years, and it was a pain reliever. Well, about 30 years ago, they found that it thins the blood, and that's something that can be beneficial possibly for those who have a heart risk or stroke risk, right? So now aspirin could actually be used off-label for that purpose. So that's the intention of an off-label, is you're using it for a different intent. And that's what we're doing here in Altium Designer. Altium Designer is obviously a PCB tool, but we're using it to create cables. So one of those things is that there are going to be features that were not designed with this intent. So a really great example of this is the bill of materials, right? If you think about the bill of materials in the PCB domain, we don't do as required. It's either yes or no, and more importantly, how much of these things do we need? We need very specific integer quantities, whereas in cabling, we may have a whole spool of something, like a spool of cable. And so we're just going to use it as required. So the bill of materials in Altium is not going to be able to accommodate that per se, right? Because it wants a specific quantity. There's going to be limitations. One of the big ones you're going to see here today is that we cannot resize simple graphics, which would be really great in certain instances. But once you draw something with line primitives and polylines and curves and so on and so forth in the schematic library tool, once you bring it to the schematic side, well, guess what? It's fixed in place. And they give you a little bit of leeway with the pins that you'll see, but generally speaking, anything other primitive you use, they are fixed in place. So we have to work around this concept. And lastly, don't call support for missing features, because if you're saying, I'd like to have this feature, and they say, well, I've never heard of this, what are you using it for? And you're saying, I'm using it for cables, they're going to say, well, you're not using the tool in its intended purpose, and we really can't provide that type of support for you. So just kind of keep these things in mind as we're moving along. And of course, you're getting WYSIWYG. What you see is what you get. So we got to work with what we got there. Okay. As I mentioned at the beginning with the objectives, one of the problems that we had was trying to do everything at once. And we realized later on that we had to separate the mechanical element from the electrical element. And if you look at this over here, here's a really great example of an electromechanical device that has both electrical and mechanical features to it. Obviously, there's mechanical all throughout this thing, but it's obviously built for an electrical purpose. And this is why a lot of finger pointing goes between the mechanical group to the electrical folks and the electrical folks to the mechanical folks, because it really is a well-balanced electromechanical device. So the question is, who would be best to create it? And to be perfectly honest, it really is the electrical folks, because obviously there's going to be signal integrity issues that the mechanical folks aren't going to necessarily know. Now, of course, there's other factors in it like thermal. There's going to be things like length and other things, maybe vibration. Those things that the electrical may not know. So it behooves the electrical individual who's doing this to talk with the mechanical, or vice versa. But a lot of times it does fall in the hands of the electrical folks to put these together. So in Altium Designer, we need to separate this concept of the electrical side versus the mechanical side. So, and when we say mechanical form as it makes sense, you're going to see situations where it doesn't make sense to represent something in its mechanical form. I'll give you a hint. A pin, when we talk about putting on pins, putting it in its mechanical form will not make sense, as you'll see here in a little bit. The electrical form electrical form as it makes sense as well. So does it make sense for us to put something that is electrical on there? And sometimes it does and sometimes it doesn't. We'll see when that makes sense as well. So what I want to show you over here is the design that I created. Okay, so I took a bunch of parts and I drew this thing up over here. And the reason I wanted to show this to you is because we need a strategy. And one of the things hopefully you see immediately off the bat here is that we do separate the mechanical side from the electrical side. Trying to combine these together will not work, especially if you have a ton of wires, right? This is a simple design. I've only got 9 wires coming out of the P2B over here and spreading them out into 2 other connectors. But if this thing has 50, 60 lines, could even be more, then obviously trying to draw this isn't going to be very realistic here. And we would want to draw something that is useful to whoever's going to assemble it, but at the same time have something that can be easily read when they're actually trying to put things together pin to pin wise. So the first thing we're trying to do is represent it in its mechanical and its electrical form, which is what you see here in front of you. Secondly, we need to get a bill of materials out of this. So you're seeing that there's actually 2 bills of materials that we can get. The classic bill of material, where we go to report, bill of materials, and there it is. So you can see it right over here. The other way we can do it, and I'm going to show you how to do this, and it comes out really nice. And I think there's some features they added in more recently into Altium that makes this a lot more palatable than it was many years ago when we first came up with the idea. But we can also put this into the actual schematic sheet. And believe it or not, what you're looking at over here, each one of these line items is a part of a symbol. And so we'll show you how that whole thing works. But the reason we had to do that is that if you talk to most people who create cables, one of the things that they require is that the bill of materials actually show up on the sheet in which contains the information to make the cable. They don't want to have a separate piece of paper that goes along with it. So this was created to accommodate that requirement. Now, if you're familiar with Altium Designer, what you know is that bills of material can only be derived from a component primitive. We cannot use any other primitive except for a component, and in this case, a symbol, in order to get a bill of materials. And that's what you see over here. This is a symbol. So let's talk a little bit more about our library strategy, because there's a rhyme and reason for everything you're seeing here right now with this particular connector. So the library strategy is this. Number one, we have to rely on what Altium calls parts. So what are parts? Multi-module components. So under the tools menu, you go in and you click on parts and you add in another part. So this would be part A, B, C, D, E, and F. You'll see this as we're going along. You're probably familiar with it if you've ever created a multi-module component in Altium. But we're using it in a little bit of a different fashion because each one of these things has different purposes. The second element of that is that we only need one of these parts in order to make it in the bill of materials. And that's important because a lot of things that we may do, we may not need its line item description every single time. I may need simply just one of those. And then later on, I'll put a quantity of, say, let's say it was a pen, I could put a quantity of 50 in here. But as long as at least one aspect of that symbol makes it in, it is counted towards the bill of material. The second part is to separate the electrical graphics from the mechanical. So again, we don't want to try to build something that is trying to incorporate mechanical and electrical simultaneously. It will not work. So we want to make sure that, for example, if we need an electrical representation, well, we draw that as such. If we need electrical here, mechanical here, so if we need our mechanical representations, we'll draw those as such. Now, by the way, these are actually two separate parts, and I'll talk about this in just a minute. And then lastly, the symbols are rigid. So I talked about this earlier. We cannot resize these symbols. We cannot edit or move the graphic primitives. So in this situation, the reason I show you is these as two separate parts within that symbol is because I may want to move this space view out of the way. A lot of times you put it right next to it, but for some reason you may have to move it because of space considerations, or you want to put something else near it that just doesn't, that somewhat interferes with it. So if I put these as one single part, then I cannot separate them out. Whereas if I represent them as two separate parts, then they can be moved around freely and independent of each other. Okay. So let's again talk about the mechanical. So why do we do the mechanical? That's for the assembler to read. And we want to give them something that is very appealing to the eye, that they can look at and say, yeah, okay, I see exactly what they're trying to do over here. And in Altium Designer, what you're seeing over here is a mix of components. So you're seeing the various elements of the symbol, along with those things that are free-handed. Also note that in Altium Designer, there's nothing electrical on this side over here. We're not using any electrical primitives. We're not using ports. We're not using offsheet connectors. We're not using junctions. We're not using wires. We're not using any of those things that could possibly be construed as electrical. This is strictly all from the drawing tools or from the symbols. As a matter of fact, I want you to take a look at this. And I'm going to flip over to the next slide here in a few seconds. And I want you to vision what you think might actually come from freehand drawing or what might actually come from the library. So take a gander at that for a moment and see if you can identify a couple of those things. Okay, so it may surprise you that the vast majority of what you're seeing over here, everything that is in some red rectangle, came from the library. The Bezier curves over here were just niceties that we drew in just to kind of represent the fact these wires are coming into it. The cable aspects of it, like the little break over here, even some parts over here, were just drawn in there just to simply represent this from a graphical point of view. Let's talk about the electrical for a moment. So the electrical is, again, for the assembler to read. They need to know what pin is going where, and of course, what wire color they're going to need as well. And in Altium Designer, all electrical primitives are used for this. Now, one of the reasons why we encourage this is because one thing you may have came to the back of your mind is like, is there a way to make what you'd call a wire table, where you'd say, hey, from this point to this point, this is for this connector, this pin will go through this wire color type into this connector with this pin. We don't have a method to do that, but what I do believe is that if someone's savvy enough, they may be able to take a net list, put it into Excel, organize it, and then copy and paste that back into Altium. Or if they know some scripting within Altium, they might be able to put something like that, of that nature, in there as well. But that's kind of why you'd want to possibly do this here, is that that net list may be of some value down the road if you want to actually create that type of table. Okay? But you still can read this. That's the other thing too, is it's still very readable just to read this. Just for a lot of pins, this can get a little overwhelming. Let's talk about the components now, because what's important here is we want to know what we have to make. And do we need an electrical representation or do we need a mechanical representation? So let's talk about a connector that's one piece. It actually has the pins in it. It has the solder cups in it, like the sub D9. So let's take a look at that sub D9 over here. So in this particular instance, we do have it represented as a mechanical, and we also represent it here as an electrical. So for this line item, the answer is yes and yes. How about a connector housing? So this Molex part that I picked out does not have pins in it automatically. You have to purchase the pins, you crimp them, and then you basically apply them into the housing here. But notice it still has an electrical representation, even though it's strictly mechanical in its physical representation. So we have it over here, and we also represent it over here as well. What about something like a connector? Well, we talked about the connector housing here, but how about the pins for the connector? So this is where people get tripped up, because here you'll see electrically, here are each one of my pins that I'm going to insert into this Molex housing. But here, it doesn't make sense to draw them out, especially when you've got a lot of things. If you have like a 50, a cable or a harness has got 50 plus wires in it, this is going to be very, very difficult to represent. Nobody could read it anyways. So we don't create a mechanical for the pins. We strictly create an electrical for the pins. The heat sink and the heat shrink and the label kind of makes sense here. There's not going to be any electrical representation, but there are mechanical representations of this. So if we go back over here, you can see that there is a heat shrink, and there is also our label as well, but there's no reason to have it on the electrical. But I do have a polling question for you. Let's talk about the cable. Now, the question I've got for you over here is that what should the symbols represent? Should they represent mechanical, electrical, or both electrical and mechanical? Okay, so we're in here. It may surprise most of you that the electrical representation, yes, mechanical representation, no. So why is that? So let me bring this back to this next page here, excuse me. If we take a look at this over here, and you'll see that there's really no good way for me to represent the cable. And as I mentioned before, as long as I have some element be represented, it will make its way to the bill of materials. So I'm actually going to jump back up here. And I think because this is just a little bit of a better way to look at it. So from an electrical point of view, it makes all the sense in the world to have the cable represented. But from a mechanical point of view, if you really look here, these things are just simply drawn in. And that gives us a lot of flexibility to make this longer, to make it shorter. And as I said, the biggest problem we have with cabling is that we really, once you create something in the symbol and we put it on the schematic, it's too rigid. I can't move it around. You're going to even see some limitations and issues with the label and the heat shrink as well. There's some tricks that we employ to do these here, but when it comes to the cable, it's just too difficult to try to represent it from a mechanical point of view. So we only treat it as electrical. Okay, and we talked about that already. So let's just jump over here. So that's the last of my slides here. We're now going to jump into Altium Designer and take a look around, and so that you can see some of what we've done specifically in the library to help this about. But I do have some warnings and just things to just keep in mind as we go forward here. You really do have to have some library experience to do this. This is not something I'd put some new intern on or somebody who's just brand new to Altium. You really have had quite a bit of experience putting together parts and knowing how the library tool works and its affiliation and association to the symbols, or pardon me, to the schematic sheet. So that's one thing here. We are definitely going to use the library in a very, very different way. We're creating things that represent that particular component, but at the same time, they're being used for very, very different reasons. Whereas traditionally, when we create something for a component, we're just representing just pins or just breaking up into different pin groups so that it's a little more palatable when we try to put it onto the schematic sheet. You need to be proficient in graphic drawing. Now, there's certain things we can get away with that we can allow other tools to do, and I'll show you those examples, but you're gonna have to be a little bit savvy with drawing lines, polylines, curves, Bezier curves, which I'll show you how to use, that there is some level of that involved in this. You'll have to be able to experiment with ideas. You'll probably have a lot of ideas that you'll say, well, why can't we do this? Why can't we do that? You really want to experiment with them because there'll be something that will poke at you, say, well, this would work, but this doesn't do everything I needed to do. And in fact, this is becoming an annoyance rather than a benefit. one experiment that, or one thing we did, for example, is we used the pin parameters. And I realized later on that the pin parameters don't really buy us anything because the assemblers can't see the pin parameters, right? So there was a lot of extra work we were putting in there, but I'm not sure it was really of value. And then to be prepared to undo and redo work, especially when you're first coming up with your library setup. It just happens. You're going to say, okay, I think I got this right. You put something down, it looks okay, then you create another part, and then you realize you missed something, that there's a differentiator that you need to add in there. And so you may have to go back to the first part to include that in there, so that now the two parts have this differentiator that you forgot to put in. And always think several steps ahead, because you can put a lot of work in and realize it just isn't going to succeed, and it becomes very frustrating. So with that being said, I'm going to bail out of my PowerPoint presentation. Okay, and let's take a look at this design. So this is one that I pulled together here for our webinar. It's kind of nonsensical, but I just figured we'd put something here so that we had something to look at. We've seen the mechanical element of this, and we've seen the electrical element of it. Okay, here's up here in the top right corner, you can see that we do have our bill of materials. And as I mentioned, and I'll click on this, each one of these things is actually a component. And of course, in the context of your schematic editor, a component is a symbol. Okay, so each one of these is actually a component. A lot of these things that you're looking at are components. Even this little note here is actually a component as well. Now, in order for all this, one last thing, there are notes up here as well. So hopefully you can see this is pretty complete as it is. Let's take a look at the library. Okay, and we're going to start off with the belt and wire. So let's go over here to the belt and wire and just show you a couple of features here that we use to get certain effects. So one thing that you may have noticed is that the pins are remarkably small, and we have them set up so that they kind of flip up over here. So what was the idea behind this? Well, if you've ever seen a cable drawing, what you may have noticed is that there's always usually some round dot in here to indicate that there's been some type of contact with that particular cable. So what we've taken advantage of is that by drawing it the way that you see it here, is that when you place one line and drop it in here, and you place another line drops in here, you get a junction, and it looks like the dot that you would expect to see in a cable drawing. So we took advantage of that concept here. As for moving things around and for colors, we did try to experiment when we first came up with these concepts with actually putting the colors in. There's kind of a problem with that, obviously, with white or yellow, you just can't see them. And so we just said, okay, well, we'll just base it on the name and leave it as such. Now, keep in mind, you can move pins. This has always been something Altium allows you to do in any one of your components in the schematic. You can't move these primitives, so I can't take that line and stretch this out. But if I wanted to, I can certainly move the pins around if I needed to. And to do that, I can click on the pins here and just hit the unlock under the properties component, and of course the pins tab. I can unlock those and I can move those around if I saw a need to do so. So at least I have that flexibility. Okay, so hopefully that gives you an idea of what this looks like. Let's go to part B. So part B, all of these parts have this thing called BOM number. And this is kind of a change because Altium added in a feature which I think is really, really great. And what that feature is that you can now do what I'll call a redirect to a parameter, or I think they call it indirect to a parameter. Where in the past, when we first was developing this, you couldn't do that. Text was solid text when it came from the library into the schematic editor, and we had to use parameters. Now, the problem we have with parameters is because, especially when you're working in a multi-module environment, is that they always show up. So if you want them to be visible, well, they will definitely be visible. So if we click over here under General, and for example, if I create a new parameter, so let's go here and create a new parameter, and I'm just going to call this parameter test, and I'll give it a simple 1, 2, 3, 4, 5, 6, just so we have something to look at, but I'm going to turn it on. And if you're familiar with multi-module, or what they call the parts here in Altium's library, once you turn this on and you move it, well, guess what? You're going to see it everywhere. So you're going to see it here, you're going to see it here, see it here, see it here. So I jumped a little bit, but there it is. And then if we go to part D, it's going to be in there as well. So it becomes a bit of annoyance when you're working in the schematic library editor. Now, once you place these parts down, each one of these things becomes rather independent. And we'll talk about that here towards the end because it becomes a bit of an issue. And we want to make sure we nip those things in the bud before we scatter them all over the sheet. So that's why we kind of moved away from using parameters and found that, hey, you can use this as text. And so if I click on this, you'll notice it's text, and you'll see the text is equals some type of parameter. Now, if you have a space in your parameter, you will need to use the double quote. If you do not have a space, in fact, it doesn't want the double quotes, as I found the hard way. So here, I'm going to turn off my test and just leave well enough alone. But that's what we do. And every single one of these parts you have has one of these call outs out. So what does this represent? Oops, turn that off here. There we go. Let's go back to our design. So you'll see the call outs all over the place. So here's the call out for the pins. Here's the call out for the cable. If we go up to the mechanical side, you'll see the call out for the plugs and so on and so forth. And that's what these are over here. These are your call out numbers that match up with these over here. Okay. So that's why we've added those into every single library, and we use the text, but we're using an indirect to the parameter to make that happen. Here's a very specific example of it. This is the line item. And so we went in there and made sure that all of these match up to those parameters that we have here for this part. So the manufacturer's part number, the description, and the internal part number. We leave the quantity blank. That does have to be filled in by the user. And just again, to show that example here, if I go to the quantity and I click on as needed, you'll see that this is just really dumb text. I put these things in there because, again, I don't necessarily want to have, for example, if I have 5 of these pins here, I don't want to have, it wouldn't know, all right? I would have to put this number in myself. So that's why we did that. Or the as needed, again, it's something I would have to put in. Altium's not going to be able to increment that automatically. So there we go, we got with that. And then here's something I've been adding in more recently too. And one of the biggest problems I have found with cables, they say there's 1 billion components out there. I am of the firm belief that probably 80 to 85% of those components are actually cable components. And you can be really well instructed and informed in one type of cable type and its plugs. And then you go to another one and you're almost starting as a freshman. You're like, whoa, okay, how are they configuring this? How are they doing this? How come they're giving me 6,000 different options? If you ever worked with the 38999s, for example, those are commonly used in military applications. There's a huge number of variants and configurations that you can put on one of those things. They'll drive you crazy. So one of the things that I would encourage you to do, and this is something we've added in here more recently, is just take a picture, throw it in there. And it's not hard to do, right? You can just simply do a place, and then you can do a graphic, and you can put it in. If I had created this from the get-go, my recommendation is this should really be part A. Now, some of you have probably dealt with this long enough to know that unfortunately there's some limitations with these parts in Altium. So when I say parts, I'm literally talking about these submodules here. The 2 major ones. So number 1, I can't just take part D and drag it up and make it part A. It just doesn't work that way. And secondly, if I really want part D's information to become part A, I literally have to cut it, go to part A, paste it, take what's in part A, move it to wherever else I want it to, and then go back and clean up everything I need to do. So it's a really big effort, and that's why I didn't try to rearrange these type of things. But if you're going to be new to this, my recommendation is make D your part. What I've got for part D, make it your part A, because that's one thing you immediately want someone to see when they're looking at a part, saying, oh, okay, this is what it represents. And that's kind of the point, and the tangent I'm going off on over here is that when it comes to cabling, a picture truly is worth 1,000 words, and it really helps when you know what you're looking at. So throwing that picture in is going to be a huge benefit in this case. So there you go for the Belden part. Let's take a look at that Molex part here. So we saw this one already. Actually, this one we've already seen in the examples. Let's go over here to our Tycho part. So here is our Tycho part, and the reason I want to show you this is because I did say you have to know how to draw, but you don't have to be that good at drawing something like this. So how do we draw something like this without spending days or trying to make it look very realistic like this? Well, you can take advantage of the fact that any step file that you have can be brought into a mechanical tool, converted into DXF, DWG format, right? You can take advantage of that. So as long as you have the step of it, you can convert it to DXF, DWG, and you can get something that looks like this. Now, because I'm a little pressed for time, I didn't want to go through that whole process of opening up SolidWorks and converting it, but it's pretty easy to get the DXF DWG. What I will do is show you how to import it in. So let me bring you over here. So I created this here so that I can do it very quickly just to demonstrate it. I do have a DXF file. I got it from 3D Content Central. So in 3D Content Central, you will find a ton of PCB components. When it comes to connector components, it's a little more sparse. So you may have to talk to the manufacturer directly, or you may have to talk to your rep, especially if you're doing 38999s. I was hoping to do a few of those, and I found that without having really a direct rep, trying to get those step files is a little more trickier. But I did find one in 3D Content Central. It's what they call a number 26 shell, and that's the one I'm going to bring in here just to demonstrate it. So I'm going to go into my file, and I will go into my import, and you got to go into AutoCAD. It doesn't say DXF DWG, it just says AutoCAD, but it is looking for a DXF DWG file. Please do give me a moment here. It doesn't remember yesterday from where I brought it, so I'm going to navigate to that particular directory, and we'll get to that here very quickly. So we'll bring this in. Okay, I'm going to bring this back here so you can see it. Here it is, the DXF file. So I'm going to click on this and press open. You've probably seen this before. It's the exact same type of thing that you would have seen on the PCB side, just that it's not demanding a layer for this here. You will have to mess with the scale. This one does remember the scaling here, so you may have to do this 2 or 3 times to get the right scaling to it. 0.01 seems to work just fine. I'm going to leave the rest of these things alone, and I'm going to press OK. And it does bring it in. So let's zoom in here and take a look at what it brought in. So one of the neat things about the conversion from STEP into DXF DWG is they will allow you to take different angles of it. So this is a round connector, right? This is the 38999 shell that you would see here. Now they're showing the exact same thing, but you have to remember it's round. So what you're looking at is the left side and the right side. You're seeing what the front of it looks like, and you're also looking at, I believe, what they call the isometric view. There's a caveat that is not really little. It's one that I want you to keep in mind. I do like these views because they really give you kind of a good profile as to what it looks like. However, just notice at the bottom right-hand corner when I select these, this is 832 objects. So if you start piling your library in with a lot of these views over here with this much detail in it, you're gonna dog down Altium quite a bit. And why is that? Because each one of these things, remember, Altium doesn't necessarily know one primitive from the next. All it knows is that it has to create a record for each and every single one of these primitives. So there's 832 primitives? Yeah, 832 primitives. So there's now 832 records that Altium is trying to maintain to keep this thing together. So if that's the case, you probably may not want to have this one. It's a nice one to have, but it's really going to dog down Altium because it's just having to maintain that many more primitives. So what would I do with this? Well, this one, as I said, I'm not going to keep. I'm going to delete this. This effectively looks the exact same. I don't need this one here, and I only need one side profile anyway, or a top profile. I'm going to take this one and I'm going to move it over, and I'm going to show you a couple of other recommendations. For this one here, I'll do a Control X. By the way, I do have my copy reference on. That's why there's a cross here. I'll grab this and it will take that. I'd make this one part B. There it is already. I forgot to delete it from my practice run, but it would be just doing a Control V and placing it down. By the way, you may have noticed it's not completely on the grid, and that's perfectly fine. This is just a mechanical representation anyways, so I'm not worried about linking up hotspots of pins to each other over here. For this over here, let's talk about part A. The one recommendation I will make is that, again, these might come in through metric, but it doesn't really matter other than the fact that you want at least one face to be on the 100 mil grid. So here I would try to move this one over. So I will click and grab it here, and I would try to get it onto the grid, just so that when I do the Bezier curves, that they will line up with the grid over here and they won't be overshooting it or sticking it. And sometimes you do have to play with this and drag it in a little bit just to get it corrected onto the grid there. But that would be my recommendation, is at least this, actually I have this backwards. Let's take this over here. I gotta flip this, my bad. Move and move section, clicky, hit my space bar twice. This is the side. I thought it looked too easy to do here. There it is. So this one I'd want to make sure is somewhat on this grid here. And if I really wanted to play with that, then it's just a matter of taking this and trying to move it over and trying to get these to just line up properly on there. So with a little finesse, you can do it. By the way, let me talk about the grids for a moment since I brought this up. You'll notice at the bottom left-hand corner, I'm working on a grid of 10 mils. You will be working with a very fine grid when you're doing cables. You're just going to have to use it, especially with the mechanical stuff when you're drawing it, because you really are drawing pretty pictures at that point in time. Okay, so just be aware of that. There is another thing that I will bring up here, and let me go back to the Tycho part, and let me bring this up. You may have noticed these weird little stunted pins. These are it's a 50 mil length pin. So why did we do this? Well, there's actually two reasons. One, we kind of abandoned midstream, and the other one was really more practical, which I think still makes sense. Originally, the idea was that we wanted these pins to be on the 50 mil grid so that if there had to be a pin inserted in there, then the pin would correspond to the 50 mil grid. And then by the time it was done, everything would be on the 100 mil grid. Well, of course, not everything requires that because, like, for example, the sub D9 with the solder cups in it, it doesn't require it. However, the other thing that we thought about too is that we don't want anybody to confuse this cable piece with something that is being used for a printed circuit board. Now, hopefully you keep your library separate, but for some reason, if some part finds its way in there, you don't want them to purchase a part that is going to be problematic. So that's kind of the history why we kind of kept these pins a little shorter here, so you knew immediately that this was not an ordinary component. It is something that's being used for cabling. So that's what we've got there. For the rest of these should all look the same. So here's the top of it. Here's the front of it. Here is, again, our BOM number. You're going to see the D, C, and E and some form of F pretty much in all the other ones. Let's talk about the pins for a few minutes. So we've got our pins here. So let's bring up the pins. So here is the electrical form of it. Here obviously is our BOM number. Here's our line item. And here is our representation. So again, no mechanical element to it because there's just no place to put it over here. Well, this is a bad example because those are solder cups, but over here, how do we really represent that? Or if we've got 50 connections, how are we going to represent that? It doesn't make sense. So that's why we have no mechanical representation for the pins. All right, let's take a look here at a few others. All right, let's get into the label. The label you'd think would be pretty simple, but it's got a lot of parts to it. The first one, so here's one of those examples where we really struggle with the idea because this is fixed in nature, or it fixed in Altium Designer. So what I mean by that is if I go over here and I pull on this, okay, there it is. And if I click on it, it is a component. So is there a way to stretch this? We really wish it would, so it looked like it was rounding about, but it's fixed. Maybe, and I've been noodling about this, is that maybe the best way to do this is just have a line with this label here, and the rest of these things could be drawn in, and that may work as well. The idea is not to create more work for the person putting this together. Also, we want to make it somewhat intuitive as well, but that's one of those hard limitations that we deal with. What else do we have in here? Let's take a look at B. Here, we need to know what to print onto each label. And again, all of these used to be, they used to be just straight up parameters. You turn on the parameters and stick them in, but now we're using the text to do this. By the way, there is a caveat with the text. You want to get it right because once you place this in, I can change this information here, but I really cannot get into its properties at that time after this. So you want to make sure that you have this set properly in the library, like the color, the justification. The justification is really important. I'm glad they've added this in here. Your fonts, whatever is necessary to get this right, because once you put it in the schematic, all you can change is the actual text. You cannot change any of its other properties, at least as far as I can find. So there is the text that we would put in there. We go to C over here. We do have a note number. So again, this is using information that would be a parameter and the actual note itself. So there's the note that would be put up in the top. So we don't want to have people try to write those or to remember those. You just want it to be a part of the symbol itself. And of course, we've got our BOM number and our line item over here. Let's just take a quick look at the heat shrink because the heat shrink is very, very similar to the label. Here's our BOM number. Here is our note number. Do we have two of those? Hold on a second. Okay, there it is. Yeah. And you can see that we built these things over time. So again, moving these things around is a little bit of a hassle. So when we originally created this, for example, we probably put the BOM number there just because, well, we'll just draw it in. And then later on realize, well, maybe we can put more information in there. So we put in a part B. We should have a note with it. And then here in part C, it's like, well, here's the note for the note triangle. And here's part D. So this was kind of a piece of it. This was a bit ingenious. I like this idea that came up. So here, the idea was, here's the top part of it. And here's E. This was the bottom part of it. So what does that look like in the schematic doc? Well, here, what we do, and I'll pull this up here, these are actually schematic parts. So if I click on this, you can see there's this designator. It is a component property. Same thing with this one. This over here, we just simply drew it in as a line just to fill it around. So these are the tricks you're going to play. So here we go. We go into part F, and then you got the manufacturer's line item information. Okay. In terms of designing this thing, one of the things that works really well is we have been using manufacturer's name, manufacturer's part number for the name, and we've been using the description for a decent description so we can make heads or tails out of it over here as the description. This is one of those descriptions you really want to have a strict rubrics for so that you can easily find things or you can sort for things here. So you can either do it through manufacturer's name, manufacturer's part number, or the description. So it just takes a little bit of work to kind of come up with the best scheme that'll work for you and your team. With that being said, I want to also place a part. And the reason I want to place a part down is because there's some caveats that I want you to be aware of. First and foremost, don't start off with part F. And yes, it will wrap around to part A, B, C, and D, and E, but in a sense, Altium's already treated that like another part. So when you put these parts down, you really want to start off as part A. So I am going to place this. The other thing that you're going to want to do too, let me zoom this out so I can get down here in the quarter, is you want to pile them all together in one area. And there's a reason for this. So I'm going to place this one. Before I do this, I'm also going to hit the tab key. Because if you're familiar with multi-module components, they're going to become independent of each other. So either I fix everything now, or I'm going to have to fix them individually. And once you scatter them, it becomes really hard to find them. So I'm going to place this down here, and I'm going to just keep dropping them until I round it about to the next part A. The other thing I did, and this is, I keep doing this, that I need to hit the tab key and put this in. So let's call this one just P10, just to have a name for it. Now, the first two that I put down will not have P10. They're that independent of each other. And there's ways I can fix that, but right now I'm going to put down the rest of these so that they will have their information. And now I've rounded about. So I have these here, and I'm not, before I scatter them off to the different corners and locations, there's things I probably want to get, I want them all to be on the same page. So for example, if I click here, you'll notice that this says P question mark. So one of the things I can do is I'm going to right, now notice how I did this. I'm not going to select left to right. I'm going to select right to left because I want anything that it touches to be in here. So I'm going to click in this and I'm going to call this P10. Now all of these will be P10, okay? Now another thing, because what you just saw over here is everything's independent of each other, I do need to fill in the BOM item number here, and I need this here as well. So let's just call this BOM number 20. So let's say this was BOM number 20, and if I click in this and I hit return, or click off of it, that was BOM 20, but notice how it did not immediately put that into the call out or into the line item. So even if I put in the line item here, so this was BOM number 20, and I click off of it here, there it is. All right, but it didn't get picked up by the call out. So again, when you have everything here together, this is when you want to try to get everything fixed as one. So if this is BOM number 20, then I'll click on this, and now all of these things have taken on that particular element of it. And you want to fill out any of these other things here as well, so that once you're done, you say, okay, I'm ready to just scatter these things wherever they need to be placed, then you know that they're all part of this, because trying to get them back together afterwards is a real big chore. Now for here's an example. Let me throw this out here and just kind of reiterate something here. So notice that I had 5 of these pins here. Notice that I only have one of these for the pins here. Where are pins? Here they are. So here's the line item 7, and it's only showing once here. I put in the number 5. So just keep in mind that even though you have all these things here, you may not need to use all of those things that are listed here. It's the same thing with this heat shrink. With this heat shrink, when I put down the first one, well, I put the note up over here. So when I put down the second one, okay, well, I put in this piece here. I put in this piece, pardon me, this piece here on the top, the bottom piece here, the call out here, and I put down the note. But there was no reason for me to put down another line item row or for me to put down another note because it's already been represented. So don't feel like you've got to put down everything that you've got in the symbol if something else is already representing it. You just need to have one part out of all of the things that you've got in that symbol to get yourself on the bill of materials. The true bill of materials, that is. If you're the one up here, if you go into reports, bill of materials, we bring that up here once it comes up. So here you can see, right, as long as I just got one representation of it here, some part of it, it's still going to show up. So you can certainly use this. You may have to ultimately, well, you will have to put this into an Excel sheet and massage it a little bit, but you can still get a bill of materials out of this, and it's perfectly valid. The last thing I want to show you over here, because I know my time's getting a little bit short and I might have some time for questions, is the Bezier curve. And so the Bezier curve is what you would use, actually I'll do it over here so you can see it, to make these lines. And they're not really that hard to use, they just got to understand how they work. So notice one thing is up here I brought in the drawing tools. This is normally under the place menu. I just didn't want to keep going to the place menu. So how did I move this up over here? Well, I'll show you how to do that. So I'm going to customize this. So I right click, customize, all right? And as a matter of fact, let me restore it so you can see how I did it. I'm going to say okay here, and I'll press close. So you'll notice I moved it back to where it was initially. So I'm going to right click on the top. I'm going to click on customize. As long as this is up here, now you can customize these things as you see fit. And there's a lot of different things you can do. But for my purposes here, what I'm trying to do is I'm going to go into place, now the drawing tools, and I want to move this. Now I have two options. I can just simply click and drag it and move it, but also I can just click it, and as I'm moving it, I can hold down my control key, and by doing that, let's see if it took. Close. Now it didn't. Let me try it one more time. So let's go here to customize. But if I hold down my control key while I click it, while I drag it, it should make its way not only here, but also in the place menu as well. So if you want to leave it in its original location, we should be able to do that. So let's try this one more time. So I'm going to take my drawing tool here, and now I'm going to hold down my control key, and I'm sorry, I want it up here. There we go. That's what I want. I'm going to let go, and if I've done this right, it should still be in the place menu, and it is. And I can press close, and now I've got it up here if I need to, or I've got it down here if I'm more familiar with that location of it. So definitely going to need this if you're going to do cabling. So for the Bezier curve, I'm going to go down here and we're going to click on this. The Bezier curve requires basically 4 points. And the first and the fourth points are basically your anchor points, right? They're going to tell you where you're going to start and where you're going to end. And the second and the third ones are going to tell you how to bend it or give you the ability to bend it. And what I found the best way to do is to try to go initially like as diagonal as you can from the first point to the other. You don't have to be perfect about it, but that's really a good start to just kind of get things, because people start dragging, then when they press end, they're like, oh, it's way off, and they get frustrated. Now just do something like this. So here's my first point. I've clicked once. I'm going to click a second point. I'm going to click a third point, and then I'm going to bring in my fourth point. Now, after I brought in my fourth point, notice that that wire is light blue, not dark blue, because if I click left mouse click again, it's going to try to draw this as the first point moving forward, and I don't want that. So I'm going to right mouse click, and it now takes this as the new Bezier curve. If I want to continue with another point somewhere else, I can do so, but I'm going to right click again just to end it. So here are my 4 points, and really now it's just a matter of playing with the second and the third lines, and pulling them as you can get them so that it kind of gives you the effect that you're looking for. And with a little practice, you can get that thing to look pretty good. All right, so there's your Bezier curve with that. So those are the things I wanted to show you today. Hopefully, I've made you a bit more curious, if not dangerous, with making cables in Altium Designer. I do have a polling question for you, so I'd like to bring that one up here. So we'll bring up our next polling question. So basically, we'd just like to know, now that you've seen this, would you be more likely to use Altium, less likely, or are you just going to stay the same? So just kind of getting an idea. Okay, so I've done my sales well over here. Looks like a good 70% of you are now more inclined to use Altium for that, or for this purposes over here as well. Okay. And then I think we have one other polling question, so let's bring that one up. Just want to know what you thought of the webinar today. Great. Okay. So I'm glad a lot of people learned a lot today. I hope that it's something of value to you. For those who are getting a refresher, I'm glad that I was able to kind of refresh those things, especially if you're not doing cables all the time. That's probably the hardest element of this, is not constantly doing them. So hopefully, if you have a regular frequency of doing these type of things, then it will make a lot more sense, or at least it'll be quicker to make them happen. And then for those who are just kind of curious, I'm glad you did, because there are other options out there as well. And obviously there's limitations to this. So it's going to be really up to you to determine if this is a good path to go, or if what you're doing is already great, or is there another tool that might be able to provide you additional things that Altium simply is not going to be able to provide you, being that we're using it off label. So if you don't mind, feel free to ask, write some questions in there. I think I can grab a few of them, but I would like to talk to you a few minutes about 9.connect. So let me bring back my PowerPoint. So you are here for a reason. And why is that? Well, cabling is just one of those things that needs to be done. A lot of people don't get very excited about the cable, right? It's like, oh, I finished the board, it looks great. And then like, oh, we got to get a cable from point A to point B. So it's kind of one of those things that unfortunately tends to be a bit of an afterthought, but they're just as important. So they have to get done, and you're always looking for the best way to create them, or probably not just the best way, but the most efficient way to create them. And you may need to see if you may need a more comprehensive tool. And by the way, as a side note, feel free to contact us about that, because we have our definitive opinions as to when to use Altium, or when to possibly look into something like E3 or SolidWorks Electrical. But here I just also want to talk about 9.connects and take it into a slightly different topic. We obviously provide training and services, but one of the things that we've actually been getting a lot of calls on lately is Concord Pro services. I think a lot of people have purchased it. They realize the power and the benefit of it, but what they probably didn't realize is the amount of effort it takes to at least get it initially configured. So we do help our customers with the configuration to make sure that it's set up the way they anticipate it and the way they've envisioned it. The library prep, this is really important, right? If you put garbage in, that's what you're going to have. If you need to clean up your libraries, that's half the battle with Concord Pro, is that you want to put in good stuff, and we can assist you with that cleanup. You also user instruction too, because it's one thing to teach the administrators how to use it, but then we want to make sure that those who are going to use it on a day-to-day basis understand how to use it as well. And we also do provide library services. Some customers are just like, you know what? Libraries are just killing our productivity. We need someone to do it. And if you're looking for us to do libraries on a continual basis, we do provide those services as well. For more information, do check us out at 9.connects. If you go under our tab for engineering services, you will see Concord Pro /Vault setup, and you can find out more information about what we can do. And by the way, if you feel like, well, we don't need Untitled to do this, but you want a couple of pointers or tips, take a look at it anyways, because we do provide some of those recommendations when you're first starting out with it. And so with that, guys, I want to thank you very much for your time. I hope you found this valuable, and we look forward to having you at our next webinar.